Okay. Can anyone hear anything yet? I'm not hearing anyone.
I can hear you.
Excellent. I don't see anyone yet either. I don't know if you guys want to turn on your video.
Well, I'm just gonna leave it off.
Oh. Heather, this is Jessica. I can't start my video. It says the host has stopped my video.
It says what has stopped it?
It says the host has stopped my video. So I think you need to click on my video.
Yeah. That's odd. Where are you? I am not in charge of your video.
You just, I will not be presenting today. I'm just here to, in case that there's a problem with the graphics or anything, that we can have a quick backup.
Okay. I would like to make you guys as panelists co-hosts though. So that's another thing that might help to make things go easier. Julie included, just because you also know Zoom and controls and can help if needed here.
Yeah, she's gonna moderate.
Yep, so I'm giving everybody co-host controls here.
Power.
Okay, Adam Ferguson, James Holt, these are just attendees that are starting to show up, right? Not our panelists, right?
Correct.
Okay.
So I don't see any video option for me either, Julie.
We're sorry, Mark, you don't get video.
Oh, okay, hold on.
That's fine. I have no issue with that.
Yeah, I don't know why it won't. It's like when I hover over to get rid of the no video, it won't let me pick it. It's very weird. So no, it's okay, Jessica.
I'm in. I'm good.
Now. Yeah, I am not, it doesn't look like I'm in charge of if your video's on. Yeah, you're gonna have to look, if you hover at the bottom, I think maybe it'll bring up your video controls.
Oh, there it goes. Start my video.
Yeah.
Ta-da!
Hey, everybody.
Yay!
Success.
And then now that you have co-host controls, you can also share screen and all those things. I will encourage people as we get started here to, or Julie, you can encourage people to send their messages directly to the panelists as chat questions maybe, or if you want to moderate, however you want to handle that.
Send them to you, Julie,
Say that
right?
again.
I don't know if you want to tell participants, to either send a question to you as a moderator, or if they want to just send questions directly to the panelists. I've just been letting people send direct questions to the panelists.
Yeah, I think that's fine. I will go in and look. So what I'm going to do is going from Sierra's email, just tell people if they're looking for continuing ed credit, a link to the quiz will be automatically displayed after the webinar is closed. And then they'll also be able to access it using a link in the Zoom chat function.
Right.
And then we're encouraging questions. We're going to take questions in the middle and the end. And then the webinar will be shared on AIA Utah's YouTube channel.
Right.
Later this week.
Yes.
Is there anything else I need to cover or?
Nope, that's it. So you're all good to go then. I'm gonna take my video and mute myself then, and I'll be here in case anybody needs to get me, just shoot me a chat message.
Okay, cool.
All right.
Thank you.
No problem.
Okay,
Jared just came by.
So I don't see any of the tools that we had before that showed up in that taskbar at the bottom now.
Try moving your cursor down there. It might be hidden.
Yeah, no effect.
Mm.
Huh.
So what about the 3 dots if you hover over your picture?
3 dots allows me to stop video. or mute audio. So I guess that's what we want to do, is stop video, right? But then how do we get the headshots inserted like you wanted?
Yeah. Oops, somebody's sharing a screen.
Me.
Okay. Awesome.
Do you want me to stop and you do
No.
something else?
No, not at all. I was just, somebody's got it.
Yeah, Mark, I'm still getting, I can see that in the drop down, it says edit profile picture. So I don't know what's going on with your settings.
Oh, now I got the bar at the bottom.
Yeah, so you can move that bar around.
Video settings, and I still don't get a profile.
Hmm.
Oh, well. It won't be the end of the
So,
world. Oh, there's Sharon.
Yeah.
It just means it's
We'll
just
live
going
with
to
it.
show my name instead of the still picture, right?
Yeah.
Same with
Yeah.
me.
When I go stop video, it's just, yeah, okay.
Yeah.
Well, I will tell you guys all, Julie knows this because we've been doing the registration on the back end, but you have over 270 people signed up today. So
Oh my God.
a large crowd. Yes.
That's good to know.
Yeah.
Holler.
I hope they get their money's worth.
Guaranteed.
So Heather, how can we help you with this? What do you suggest?
I mean, now I feel like the crisis is handled. getting it taken care of for the month. I just, it's all kind of relatively new. I thought that it would cap itself at the 100 people that it said our webinar was, our package was at, but we handled it with a quick add-on here for the month, which we're going to have to do for conference anyway. So I guess this is kind of a dry run to see how it will go. It was just, I just didn't expect it. I did not. Well, honestly, I didn't know we'd have that many people sign up, which is great for you guys. Also, I didn't know that we wouldn't cap it at the 100. So there we are.
People just go into a waiting room, right?
Yeah, and I also don't know, because it doesn't give us a lot of controls overall, the messaging on the back end. If those people who signed up after the 100 like got a message that said, you know, if this is full and you'll be added to a waiting room. I don't know if that's what the form said. So I wanted to hurry up and remedy it to make sure everybody could get in there, hopefully.
We had some employees that probably signed up today, so we would,
Okay.
you know, if they received an email, we would be able to find out.
Well, I mean, no, everyone's still able to register. I just had to change the number of seats in our license in a hurry to get 500 people to change the threshold.
So do I understand then that was fixed? Maybe Dorian, we could send out saying that people could join.
We already
did, Jeff.
Oh, okay.
Yep.
Yeah, Julie, to allow me to save face, Julie went out and sent the email.
We got it though, I think.
So.
But yeah, so you'll have people here show up in the next few minutes. It's been, I don't know how you guys have seen your digital meetings go, but people have been relatively prompt. And then if you kind of start on time, the stragglers will make their way in the next few minutes.
Sounds good to me.
All right, well. No, otherwise I will just, yeah, I'll let you guys handle the introductions. I will remain quiet. I might have to answer another phone call or something in here, so I'll just keep myself.
So are the people that are participating right now able to see what we see? Or do we actually start it and then they can see?
The webinar has been started, so they can.
Okay, so they just heard what I said. All right.
Hello, everyone.
Guys.
So yeah, I guess that's kind of what I was saying. I guess heads up now, you've got people joining from like now until noon.
Okay.
Do we see any kind of indication of people joining, or is this all we're going to see?
So as a co-host, on the bottom bar, do you see a little thing when you roll over that says participants?
Yeah, we got 15.
Okay. So that should tell you the number of people who are joining, or if you click the chat feature, you'll see, people that you can respond to in the list of chat folk. But yeah, I would say since you've got like 272 people signed up, once you reach, I guess, 100 or more here right at noon, I would say you're ready to go.
Okay, well, I'm going to turn off I'm going to go on mute and turn off my video until we're ready to.
Okay, I'm just going to send a chat to all the participants as anyone joins to welcome, and just be patient as we get ready. Okay, I don't know if anyone can hear me. This is Heather Wilson. Hopefully our attendees can hear. We are right at noon. And I know Julie is from Reaveley is ready to get us started with introductions to our panelists today. Oh, good. I'm getting lots of messages that they can hear. Great. So then I will just hand this off to Julie and the team. I want to thank them for pulling this together and having such great information available for us. As we all know, our Earth literally shook for us here in Utah, along with so many other things that are happening at once. And all the things that we can do to connect and educate ourselves around resilience are of high value to us right now. So I want to thank everyone for participating. And with that, I'll turn it over to Julie and Reaveley.
Thank you, Heather. Welcome, everyone, and thank you for joining us. Before we begin, I have a few housekeeping items to cover. If you're looking for continuing education credit, a link to the CE reporting quiz will automatically display after the webinar is closed. You can also access the quiz link using the Zoom chat function. And speaking of the chat function, questions are encouraged and will be addressed at the middle and the end of our presentation. So please type your question in the chat box. Today's webinar will also be shared on AIA Utah's YouTube channel later this week for viewing after that CE quiz closes. Reaveley extends our thanks to Heather Wilson, Sierra Parkinson, and Jared Ma for their help in making this presentation possible. My name is Julie Attic. I'm Director of Marketing at Reaveley. And today what we'll be doing is giving an overview of Magna's earthquake, as well as share photos and memories of the damage that we observed that day. The photos will then shape a discussion around the code provisions intended to prevent the damage, as well as code performance. The team will also give a brief overview of ATC 20 and the need for training, certification, and coordination within our AEC community. I'm joined by 4 of my coworkers, Dorian Adams, Jessica Chappell, Jared Johnson, and Mark Harris. So while it's been 3 years since we felt that morning earthquake, there are moments that still stand out so clearly for me. The concrete pendant light swinging over my kitchen counter and the coffee spilling out of my mug and onto the table. The shaking seemed to go on forever, and then it finally stopped, and then all was quiet. That quickly changed. Texts began flying as friends and family checked in on one another. My power came back on. And shortly after the 4.6 magnitude aftershock, I got a phone call from our receptionist. She was telling me of all the calls she was getting for building inspections. I texted our firm president, Dorian, asking if I could go into the office and help, and he said yes. I was too afraid to get in the shower, so I simply grabbed my dog and drove to the office. My 5-minute commute seemed surreal, and all I kept wondering was how this day would unfold. At the office, I went to our command center leader, Robert Godfrey, to get instructions on how to field calls. A live Excel spreadsheet had been created to log the calls in, and then Robert pointed out the key questions I needed to ask so that the inspections could be prioritized. After that, I sat at my desk and began answering the phone. I could hear the emotion in the voices of the callers, uncertainty, anxiety, and maybe even a little fear. One call I'll always remember came from a realtor and his client. They were standing inside a home in the avenues looking at zigzag cracks that ran from ceiling to floor. The buyer was supposed to close on his home that afternoon at 5. They were desperate for someone to come look at the home and wondered aloud about filing an addendum. After that, I soon created a list. As an engineer was leaving the office with his hard hat and safety vest, I made note of it. I kept track of where he or she had already been and where they were going. And it proved really helpful as clients began calling. Shortly after 1 or so, we took a small break for lunch. And while we were eating, we felt 2 big aftershocks that took place within 5 minutes of each other. It was then that I realized how much structural engineers live for these moments they've studied about and designed for. So Jared, I recall texting and talking with you that morning as you ran from the city and county building up to the state capitol. How did your day unfold?
Well, Julie, thank you. I had a parallel experience. I was getting ready for work that morning, and I literally had one shoe on and was getting ready to put the other on when the event struck. You know, felt the rattling of my home and immediately ran down the hall. And my wife had come out of the bedroom and was ready to scold me for having shaken the bed. And I let her know that it was an earthquake. Checked on the kids. Was a little disappointed that my teenager had slept right through it, not even realized it. And then my phone started ringing, and it literally didn't stop all day. It was a busy day, and as Julie mentioned, I visited the city county building to have a look around with Ori and Goff, and then up to the state capitol. And after that, pretty much was a blur the rest of the day and the days that followed. So we had a 5.7. That has become part of our regular dialogue now. A lot of us understand this term and we use it frequently. But what does it really mean when we say we had a 5.7 in Magna? Well, there's a couple different ways that we look at earthquake intensity and the meaning of recordings. Two of the measures that I'll talk about today are the modified Mercalli index and then the moment magnitude. The modified Mercalli index is a measure of basically perception of individuals and what they felt as a result of the event. As shown on the left and color-coded on the map, we can see the various experiences that individuals throughout northern Utah had in relation to the event. My own experience, you know, I don't have a wealth of experience sitting through earthquakes, but it felt moderate to me, so about a 5. And that seems to be consistent with the experiences of a lot of people throughout the area. So that's a very subjective measure. You know, what did we experience? But as engineers, we are very analytical thinkers, and we want to look at you know, some of the more objective ways that earthquakes are measured, and that would be with the instrumentation and looking at moment magnitude. So as we look at this chart right here, we can see you know, the bell curve representing a whole bunch of different earthquakes. The magnitude event being a 5.7, falling right there about the middle. As we look at the scale on the left-hand side of this chart, this is the moment magnitude, and for each full number increment, we have a 10-fold increase in the amplitude of the event as it moves the surface of the earth. So that's that logarithmic scale that we're accustomed to. The energy equivalent to that, however, if we look at the scale on the right-hand side, represents a 32-fold increase in the amount of energy that is released. And so we can look at this curve and some other earthquakes and other events and see the relative comparisons. Now, how do we know all this? We have a great number of recording sites throughout northern Utah. Here's just a smattering of a couple of them, their relation to the epicenter and the amount of acceleration that was recorded. And for each one of these sites, we can take the acceleration records and analytically, you know, using our numbers as engineers, we can look at those recordings and see that intensity and what it actually means in terms of shaking of the surface of the earth and in shaking of buildings that are, of course, connected to the earth. One of the tools that we use is the response spectrum, we call it. And what we can do is we can take any earthquake record and we can develop a response spectrum. And this gives us a measure of how structures in general respond to that acceleration record. The horizontal scale of this chart represents the flexibility of buildings, the flexible structures being on the right and the stiff ones on the left. And then the vertical scale represents the force. And we can see toward the left-hand side, the short, stiff structures are the ones that respond with a lot more shaking or a lot higher intensity and a lot higher force. And this is, in fact, what we saw with a lot of these unreinforced masonry buildings out in Magna as they experienced this shaking. So the response spectrum is a good tool to use to help us understand how structures respond. Now, as we look at a couple of other spectra at two different sites, on the left, we have the Lee K site right out near the epicenter with the blue line representing the spectrum developed from that station and what it recorded. And on that same chart on the left, the green line represents what the code would prescribe at that particular site. On the right, we look at the Brigham Young Park downtown, and we see the green line far above the blue line, showing us that the Magna earthquake represented only about 1/5 of the design forces that we would typically look at for the downtown area. So the takeaway from this chart on the left, particularly with the Magna quake, is that we cannot really accurately predict the intensity of shaking. As designers, we're far better served to look at how we design and detail structures to respond to earthquake shaking rather than trying to precisely predict the intensity and nature of shaking that's going to occur. So we had a lot of experiences that day, had a lot of opportunities to go out and look at structures. Dorian, show us some of the observations that we made.
Yeah, thanks, Jared. So that morning, I was up getting ready for work during the day and felt the shaking, walked around the house. Didn't seem like it was a very large event to me. And so I just went about my same routine, getting ready for the day. And then my phone rang. I got a phone call, got another phone call from building owners wanting us to go take a look at their buildings and assess the damage. So I realized quite soon that this was going to be an urgent matter, that there would be many owners and buildings that we would want to go take a look at, and we'd be asked to go and assess. One thing that we did notice is it didn't take very much damage for buildings to be shut down. In some cases, no damage at all. Building owners were just not comfortable having their employees go back and go back into work without an assessment being done. And that was the case for the city and the county. And in fact, the city and county do have assessors, they have inspectors. And so they could have done their own assessments on their own buildings, but their inspectors were busy in Magna looking at the most severe damage. And so the city and county had reached out to the design community to help them. We also saw that job sites were shut down. There were many job sites where the superintendents and project managers were just not comfortable having their employees go back in and go to work until an assessment had been done. Anyway, the takeaway is that this relatively moderate to small event caused a huge amount of disruption. And when a larger earthquake comes, it will just be even that much more significant. Now I'd like to show you a little bit more some of the damage that we actually saw. A really important part of building structures is the connection between walls and roofs. Here you have an embed plate that's popped out the face of a masonry wall, and that connection has basically failed. There's not much strength left. On the other hand, the next photograph shows that there is this similar kind of connection with an embed plate and headed stud anchors that are anchored into the wall with some reinforcement. So there's a little piece of rebar there that's holding that in, and there still is some residual strength in that connection, even though the concrete has spalled out. The next photograph shows an expansion joint between buildings. So we all know that when buildings are placed close together, that there needs to be an expansion joint that can accommodate the movement between the two buildings. In this case, the expansion joint cover was very stiff and rigid and popped out when the movement occurred and caused damage in the floor right there. What we look for is more of a flexible joint cover that can accommodate that movement. And then when you have interior partitions, in this case, it's a masonry wall that has been damaged because it was placed too close to the primary structure. So when the structure moved side to side, it caused a failure and a crack in that partition. So even though this looks very serious, and the building engineer thought that this was a really serious concern, when we looked at it, it was just a non-structural partition wall. And had there been a little gap placed between the top of the wall underneath that concrete beam, this type of failure would not have occurred. We also want to pay attention to falling hazards. So anything that's heavy and high up in a building, you want to make sure that it's anchored in. This is a piece of concrete that's just a cap between precast double T's, and it's leaning over, about ready to fall. And the next photo shows the same thing, however, it had fallen. So just an example to make sure that heavy items are braced and anchored properly so that they don't hurt anybody if they fall over. Ceilings happen to be very susceptible to damage during an earthquake. The code provisions do go a long ways, at least the current code provisions go a long ways to help make sure that this type of failure doesn't happen. But you can see how the T-bar grid has fallen in, and then the light fixture is just hanging there by the electrical cord. On the other hand, you see the photograph here where the T-bar system and some of the ceiling tiles has fallen out, but the light fixtures are independently supported as required by code. That way they have not fallen in, and really the damage and the injuries could be caused by these heavy light fixtures as opposed to the lightweight ceiling tiles. And then another provision regarding ceiling construction is that the perimeter edge angle around rooms is required to be 2 inches wide. That way, when movement occurs, there's enough length of that angle that doesn't allow the ceiling grid and the T-bar to fall off. In this location, the edge angle was only about 1 inch, and that whole section of ceiling fell in. There's a lot going on in this photograph. Obviously, quite a bit of damage. You see ceilings have fallen in, but actually what happened here is the ceiling did fall in, but the corridor walls are made out of unreinforced masonry. And unreinforced masonry bricks at the top of the wall fell in and brought down more of the ceiling with it. So if you see, one thing I'd like to point out is this is in a corridor. When the ground shook, if there would have been people in this building, it's likely they would have wanted to leave and exit as soon as possible, and they would have been walking or running down this corridor as this damage occurred, which would have been very, unsafe situation. The other thing that I'd like to point out is mechanical and electrical systems should be braced and anchored, and especially the anchors that are used to brace them should be designed for the sufficient amount of force. Here you see 2 linear fluorescent lights where they've lost one of their support and just hanging in the space. And then the next slide shows a section of ductwork, that oval in the middle. There is a round section of duct that used to be there, and it was anchored and it was braced. However, the connections between that bracing and the wood structure above failed. So the screw just basically pulled out of the wood and allowed that section of duct to fall down. Again, a reason to make sure that the anchorage is designed for the proper amount of force. And chimneys also very susceptible to earthquakes. You can see how this is 2 separate chimneys, and they're just basically on the verge of collapse right now. And the next photograph shows where one of the other chimneys on that same building had actually collapsed. All the bricks were scattered all over the floor or the ground, and you can see the steel cap, the chimney cap just laying there. Luckily, no one was there and nobody was injured. We have a lot of unreinforced masonry buildings in the city. This is one of those buildings where you can see some cracks that have developed. Unreinforced masonry is basically clay brick that's laid up in oftentimes multiple wides, either 2 or 3 wides of brick, and it's laid up with mortar, and there's no reinforcement or any other kind of anchorage that holds all of that together. And so when the seismic forces come, oftentimes you get sliding between the bricks and the masonry, and so, bricks and the mortar. And so what you see here is that sliding that has occurred and allowed gaps to open up. And this next building has quite a bit of cracking. You can see in that wall pier in the lower level of windows, there's an X pattern that developed there. When the ground motion goes one direction, you get sliding between the bricks and the mortar called bed joint sliding. That happens in one direction and creates a crack. And then when the forces go the other direction, you get another opposing crack. And so you get this X pattern, which is very common. And right now, this particular building has used up most of its available strength to resist seismic forces. And it's pretty much as good as it's going to get right now. Out of plane forces with unreinforced masonry is another item that's susceptible to damage. This wood beam was anchored into the masonry, and as forces went perpendicular to the wall, it pulled out a section of the brick. Luckily, that beam didn't fall, because what you don't see in the photograph is another section of bracing that's holding that beam up. And then this next photograph shows how roof to wall connections are so important. The connection between this roof structure and the wall had failed and allowed that roof ceiling or that roof structure to collapse. We want to make sure that there's strong connections between roofs and walls. Brick veneer and stone veneer are also susceptible to damage. When you have a motion in one direction, you have a wall that's in plane, and there's at the corner, there's a wall that's out of plane of the motion. So there's a difference in movement between the in-plane wall and the out-of-plane wall. And that difference in movement needs to be reconciled at the corner. And if there's no joint or other method for that difference in movement to occur, then you'll get a crack and some damage like this. And so that's what you see in this photograph. And then stone veneer, here we had a large area of stone veneer that fell off the building right in front of an exit. Again, very dangerous. There could have been people in the building that wanted to leave at the same time that the stone veneer had fallen off. What we learned is that whole section of wall above the door had fallen in, and there are anchors there, but probably not enough anchors, or the anchors were not strong enough to hold that stone in place. And tall contents. So we think about building structures and non-structural elements, but we also need to be aware of the contents. And tall contents tend to fall over. You can see how these photographs show shelving that has fallen over because it wasn't braced and it wasn't anchored. And then partitions. So interior partitions. We think about gypboard partitions as a non-structural element. The way to minimize the damage of non-structural partitions is to make sure that there's a separation or a movement joint between the top of the partition and the underside of the floor structure or roof structure above. Usually that can be done with a deep leg track or some other sort of sliding mechanism that allows the roof structure or floor above to move differently than the wall below, isolating the partition from the structure. So that's the end of the photographs that I was going to share. Julie, I'm wondering, do we have any questions that we could answer at this time?
We do. I'll start with a question that Fred Cox submitted. He said, how come the quakes don't follow known fault lines in Magna?
I think I'm going to defer that one to Jared. What do you think, Jared?
Well, we're still in a state of learning about this earthquake, and I've made comments before that it's probably going to be quite a while before we really understand all of the nuts and bolts and the fault mechanisms and everything that happened with respect to this event. We do have tracings of the Wasatch Fault and other subfaults that go throughout the valley. And this one, though not entirely understood, we are gradually beginning to learn more and more about it and how it correlates to the other faults and mechanisms that we do know with respect to the Wasatch Fault.
I'm going to chime in there. Our friends at the University of Utah Seismograph Station and our Utah Geological Survey folks would be really well suited to answer those questions for you. You know, seismology, you know, go to the source of the information. We're really good at staying appraised of the most current information, but ultimately they're the ones doing the hard work on the science end of that.
Yeah, and Trent Parkhill points out something helpful. It says 80% of earthquakes don't happen on known faults because most of the faults are hidden by soil cover. Trent has a question. How does one assess the post-earthquake condition of the many connections that are hidden above suspended ceilings? Dorian?
I can answer that, sure. So we did many assessments, and what I looked for, I looked for non-structural damage. I looked for enough movement that could have caused a structural concern. Usually the non-structural elements in a building will show damage before the structural elements do. So I focused on where I saw non-structural damage. We looked above the ceiling and we could see if there were any, movement in the covering of the ceiling, or in some cases there was fireproofing that had covered up some of the connections. We actually did remove fireproofing in one building I was at because there was some damage nearby it. But it's very challenging. Had this been a larger event, that would have been a bigger concern. What I did observe, however, was that there was very little structural damage, and most buildings had no structural damage whatsoever. It was only non-structural damage that we observed most of the time.
Trevor Jones asks, what is a typical retrofit system for unreinforced masonry? Are there codes, design guides, or other engineering or design resources you could recommend?
You want to take that, Jared?
I think.
Sure. I'll take that. We deal with unreinforced masonry structures quite frequently. You know, we have a huge inventory, somewhere between 140 and 180,000 unreinforced masonry buildings up and down the Wasatch Front. We are fortunate to have modern codes for evaluation and retrofit of existing buildings, and chief among those is the ASCE 41 standard that helps us to evaluate unreinforced masonry and really give credit where credit is due. Unfortunately, unreinforced masonry rarely can be demonstrated within our numerical models to have enough strength. And so quite often we're looking at reinforcing unreinforced masonry by either putting a layer of reinforced concrete on it, or sometimes even with light gauge metal or regular red iron to brace the unreinforced masonry structures.
Thank you.
And I'd add that, you know, composites are used sometimes as well.
Yeah, Stephen has a question, and I believe Jessica is going to be addressing that in regard to, you know, the city and the county reaching out to our design community for assistance. Jessica, you'll be touching on that, right?
I will. All right. So at the same time, the folks in our office were busy bustling around the valley, assessing buildings. EERI, the Earthquake Engineering Research Institute, began their virtual earthquake reconnaissance efforts. EERI is a multidisciplinary national organization with a local chapter. Reaveley's actively participated in national conferences and local workshops and have participated in leadership. Craig Wilkinson is currently serving as chapter president, and Jared is a former board member. EERI has a long history of boots on the ground earthquake reconnaissance for major earthquakes. In recent years in the digital age, they have developed a procedure for virtual reconnaissance based upon information publicly available in the 48 hours following the event. Through this process, they generated a report summarizing the characteristics of the Magna event. So the VERT team uses a Slack channel to quickly gather public reports, newspaper and news articles, and I'm going to recap some of the high points of that report. So these first two figures are actually diagrams that were generated on the USGS website almost immediately following our event. So based on the size and characteristics of our community, USGS estimated that we'd have 0 to 1 casualties, and that includes fatalities and major injuries, as well as estimating our economic losses between $10 and $100 million. Both have proved to be accurate based on the information we have now, 3 months later. So some impacts to the community. Everybody knows that hospitals and schools are kind of form those cornerstones of our community. Hospitals were largely remaining operational, no loss of functionality there. The University of Utah opened an emergency command center per their emergency plan. And some clinics were closed for building inspection, some of the older ones. But ultimately there was not a significant reduction in operations. So one interesting thing of this earthquake occurring within the pandemic, the coronavirus pandemic, the coronavirus hotline in the state was down due to an evacuation of the building. Additionally, the state testing lab that was processing the COVID-19 tests was also down, but was able to resume operation within 24 hours. So with our schools, as we all know, the schools had been closed due to the pandemic. So students were not in session, but all of the schools in the Salt Lake Valley were closed to all staff, pending evaluations by engineers. So there was significant damage at Silvercrest Elementary School, Westlake Junior High, and Cypress High. Additionally, the Browning building was closed to wait for an inspection. And then moving forward with housing impacts. So most of the impacts to housing was in the modular home communities nearby the earthquake. There were 49 homes that were marked as uninhabitable or restricted access due to foundation failures. Additionally, chimney damage was widely reported in unreinforced masonry homes and apartment buildings in both Magna and Salt Lake City. And then in the early stages after the earthquake, the Red Cross opened evacuation centers at Valley Junior High School and Taylorsville High, but most residents were able to relocate with family. So those weren't needed for an extended period of time. So the Utah Geological Survey reported liquefaction events. So liquefaction occurs when saturated soils lose strength when subjected to ground shaking. In the case of sand boils, the upper sand soil layers collapse and force the saturated sand to the surface. In more extreme cases, this phenomenon can cause significant damage or building collapse when it occurs under building foundations. And in the case of the Christchurch earthquake, liquefied soil can even swallow cars. So impacts to transportation. The largest impact, of course, was widely reported upon at the Salt Lake International Airport. There again was no significant building damage, no structural damage, but a water line break ultimately closed the airport for a good amount of time and caused some disruption, of course, in our community and anybody who was trying to fly through Salt Lake at the time. So additionally, the challenges for the emergency response included dealing with rumors of a magnitude 9 earthquake. Julie had an image of a Twitter message from the Department of Emergency Management saying, no, there's no prediction of a magnitude 9 earthquake. So that, I think that's caused a lot of energy to be spent in controlling those rumors. Additionally, this was our third emergency declaration in recent days, and the other two were, of course, coronavirus related. So everything was a little bit complicated for our emergency managers. So this report, again, is just an example of the engineering community that is invested in learning from each earthquake event. Ours is a profession where we learn from examining the latest problems and failures. These type of quick response reports help determine if elements warrant further study, and we work to participate in ways that are meaningful to our community. So going to my personal experience, I live about 15 miles from Salt Lake City, and I was getting breakfast, heading to the office when the earthquake hit. I saw some flashes of light out my kitchen window, which I learned later were transformers blowing. And my whole family woke up. Everyone was still nestled in their beds. And after comforting everybody, checking on everybody, I quickly grabbed my mobile device and got on the USGS Did You Feel It website. So that was followed with texts to colleagues and family, trying to figure out where this occurred, where was the epicenter, and how big was it? So throughout the day, I felt 3 more significant aftershocks. One on the parking deck of our building, where it felt like the ground was bouncing underneath me. Another one on the 4th floor of our concrete frame office building. It was swaying, made me a little bit dizzy. And then the 4th, I actually felt while I was walking to the grocery store, and I felt the asphalt rolling underneath my feet. So pretty unique, pretty exciting. And I later learned from one of our contractor teams that they initially thought someone had run into their construction trailer in Spanish Fork, Utah. But on the steel frame building, they were able to feel swaying due to that earthquake, again, all the way in Spanish Fork. So we jumped at the chance to team with a company called Safe Hub. They offered to let us demo some of their building monitoring devices. And so we were able to get those installed in advance of the aftershocks on April 16th, the magnitude 4.2 earthquakes. So I got really quick inquiries. How big was our earthquake? what was the movement? What was reported? So what you're seeing on the screen is a graph of the lateral movement of our building. So essentially we're moving north, south, east, and west. And we're seeing what amounts to 2 millimeters of total movement. So everybody seems surprised that that was only 2 millimeters of movement for those folks that were in the office. And ultimately, I think it's just a really unsettling phenomenon to have the ground move under your feet. So this is a graph that's generated by the seismograph stations up at the U, and they are reporting as of June 10th, 2,289 aftershocks. Thankfully, most of them have not been felt by the community. So this next little clip is a really interesting video. So our earthquake was essentially a small one, right? It's moderate and is our first significant earthquake. But you can see that this video is actually showing the waves from our earthquake hitting the seismograph stations all across the North American continent. So, you know, it's pretty impressive that we have that kind of information available. So our, this next map is similar to the one that Jared showed, and it's meant to capture shaking intensity, and it uses the same scale, the MMI scale. So you'll notice we've got a star where the epicenter of the earthquake is. That first circle is showing where the shaking was felt the strongest. And as we move out, those are meant to indicate a slight reduction in shaking as we move away from the epicenter. So you'll notice these rings are not concentric circles. So you can see that the intensity correlates with the mountain ranges. So you might have had a family member or a friend in Sandy who maybe felt a shaking that was more intense than you did on the East Bench in Salt Lake City. And so that's due to the geologic formations that are under your feet at the time of that earthquake. Now, ATC 20 is one that everybody is you know, really excited about. Steve had the question about the program. So in Utah, the Seismic Safety Assessment Program is a sub-committee of the Utah Seismic Safety Commission. And right now it is chaired by Jim McClintock of Sandy City. And we have a formally established ATC 20 standard for building assessments. So under USAP and emergency managers, building placarding carries the weight of the building official or the authority having jurisdiction. So this is different than a privately arranged building assessment, which are professional opinions. So for the Magna earthquake, all of the tagging of the buildings were done entirely by city and county employees. And there were two reasons for this. One was, given a small earthquake with moderate damage, there's less of a need for inspectors, less risk of collapse for these other buildings. So again, we've kind of touched on the pandemic and its effects. So that was one more factor as building managers or building emergency managers, excuse me, were making these decisions. They didn't want to bring in any extra personnel. They were already facing challenges with social distancing and operating and keeping all of their staff safe. So placarding is a term used for posting a building with a red tag for unsafe, a yellow tag for restricted use, or a green tag for unrestricted. It's important to note that placarding speaks only to the health of the building structure. A green tag does not necessarily indicate the MAP systems are functioning. For instance, even when assessments are not performed, even when assessments are not performed by the building official or volunteers, many people still use ATC 20 as the standard. And so many organizations have their own staff trained. So for hospital facilities teams and other organizations, they will use the ATC 20 protocol. So certification is done through the state of Utah, through the Department of Emergency Management. Right now there are two classes of inspectors. One, you have to have a structural engineering license. And the idea is that in a major earthquake and in more risky buildings, you'd make sure you had a licensed engineer there out as one of those team members. So smaller earthquakes can be harder to assess. There's no reason to use large cordoned areas, but for looking ahead to a large earthquake, there may be times when a very large part of the city is cordoned off, where nobody will be able to enter the region until everything's been assessed. And the standard for that is basically 1.5 times the height of the building. So state of Utah has done some modeling based on our largest earthquake. And essentially, there is a projection that there may be 300,000 building inspections needed after a magnitude 7 earthquake. And they estimate that that would take about 2,400 inspectors. So right now the state has approximately 200 certified inspectors. And so many of these people will need to be volunteers coming from out of state. And they'll be responding to an emergency request. So some of the programs that we have right now that can help us in preparing for future earthquakes. I think a lot of people are familiar with Fix the Bricks. It's a very popular program in Salt Lake City where you can get some federal funding to help with the costs of doing some incremental improvements to an unreinforced masonry home. So there's actually a really big backlog on this program. It's very popular and it's won some awards. So on the right of the screen, you'll see a cover for P58. This is an assessment methodology that you can use for new or old buildings, and it can give you an idea of the cost of repair of your building and the downtime that it might take to get those repairs done. Okay, so last thing that I'm going to talk about is a pretty exciting program. Right now, the state of Utah and FEMA are engaged in an effort to develop a pilot program. And essentially, this is a national strategy to invest in mitigation. There are a lot of studies out there that talk about how it's basically 6 to 1. You can spend $1 in mitigation and it will save 6 in repairs. So there's a lot of work that's been done over the years. So it's building upon previous work that has been done. So in June 2019, there was a URM summit put on by the state and FEMA Region 8 that highlighted our unique risk. Part of the issue with that is that while certain communities stopped allowing, certain communities stopped allowing unreinforced masonry buildings to be built. We continue to build them into the 50s and 60s. So we have a very large building stock of these structures. Again, as you saw in Dorian's photos, they are a little more vulnerable. So the goals here are, what we're doing with this pilot program is setting up some goals on how we can reduce our hazard. So some of the things that have been talked about have been maybe committing to have our schools be URM free by 2033. That would be the 100-year anniversary of the Long Beach earthquake. And there are some limited hospital facilities that are unreinforced masonry. Perhaps we could set a timeline for retrofit or replacement of those. So there's a lot of great ideas out there, and there's a lot of effort to bring some mitigation dollars to our community and reduce our exposure. So Jared's going to talk about another program that will help us get ready for that earthquake recovery.
It's really easy to have that 20/20 hindsight, looking back on an event and look at how we may have been prepared. But one of the resources that we have currently that has been adopted by Salt Lake City, by Murray City, and by Farmington, a couple other jurisdictions are looking at it, but those are the only 3 that have officially adopted a program called BORP, which is an acronym for Building Occupancy Resumption Program. And this allows building owners, stakeholders, or managers to preemptively prepare for ATC 20 inspections. They can retain the inspectors, the engineers, or other professional personnel to do the inspections, and in a declared state of emergency, those individuals become automatically deputized by the authority having jurisdiction. And they can in fact be authorized to go and perform the inspections and the placarding of buildings without even having any conversations or having been given the green light by the building managers, because that would have been taken care of preemptively. So that's something that we think can be of great use to those looking to the future. Also, as we look, every earthquake, every significant earthquake seems to have its ramifications in terms of code development. For instance, the 1994 Northridge earthquake significantly changed how we look at moment frames and their design, and those effects are still being felt today with ongoing changes in how we do moment frame connections. But we can probably expect that on the west side of the valley, the codes in the future are going to prescribe higher design forces for buildings built within the vicinity of that fault, maybe even a larger region than that. So as we look ahead, there are a lot of things that we can anticipate and absorb as we move forth. Mark, tell us about some of the things that you're considering in that regard.
Thanks, Jared. Before I jump into that, I'm going to share my own personal experience of that day. On that morning, I happened to be in my basement riding my bike trainer. I was climbing a virtual hill in New York City's Central Park when my wife came bounding down the stairs, stuck her head through the door and said, "Did you feel that?" And I said, "No, I feel nothing. I got completely cheated. Spent all these years as a structural engineer looking at the design of buildings under seismic forces, the biggest event to hit our personal community, and I felt nothing." Luckily, a few days after, a couple weeks after that, I was at the office in the aftermath of that 6.4 event that hit in Idaho and felt a very significant wave roll through our building that evening. Anyway, as we start talking about the lessons learned, Dorian showed a bunch of pictures of observed damage that we saw as we reviewed buildings throughout the valley. For years, the structural engineering community has been touting the vulnerability of URM structures, and we certainly saw that even under this modest event, they sustained significant amounts of damage. The Magna event was 5.7. However, the Wasatch Fault has the potential to generate an earthquake in excess of magnitude 7. This means the maximum earthquake that we can expect to see could release nearly 100 times the energy of the Magna quake. You can imagine if we saw this level of damage under that modest level of shaking, what will happen if that large event hits. Jessica talked a little bit about having 300,000 buildings needing inspection, and with the inventory of URM that we have, that could be a major problem. So the safety of URM has certainly been validated, our concerns regarding those type of structures based on this modest event. The takeaway is that that major event will see significantly more damage, and it will impact a large number of people and a large number of buildings. The next thing that really spoke to me was the amount of non-structural and cosmetic damage that was experienced during this modest quake. We were quite surprised at the extent of these kind of elements being damaged in the buildings that we all set out and reviewed. Even buildings that are very new experience things like some level of ceiling collapse. And this kind of disruption certainly can affect the ability of occupants to evacuate the building. But more than that, it makes occupants of those facilities question the post-earthquake safety of their buildings. And we were very surprised by how little damage it took to get a building completely closed. A number of the buildings that I personally reviewed had no damage whatsoever, and they had been completely closed to occupants pending a review of an engineer. Again, this is one of those issues that when you start talking about 300,000 buildings needing an inspection and realize how long it will take for us to get through those, what a significant impact that'll have on the community. I want to talk a little bit about response time. Julie mentioned that she got a call on early in the morning of that quake, reported to the office, and there was kind of a response team set up that we had established. We were inundated with calls for buildings and for review of buildings in the first few hours after the event. We quickly put a system in place for getting requests for building reviews on a spreadsheet that tracked relevant information that we needed to evaluate them, such as, is there any visible damage? Were there any injuries? Has the building been closed to occupants? And how critical is a review of your building to continued operation? During that first day or so, we visited a lot of buildings. We didn't have a standardized report generated at the outset. So we realized that the information we were presenting and gathering wasn't uniform. We quickly generated a standard evaluation form that all of our engineers used to gather consistent information and present it in a coherent and uniform manner. The other thing we talked about was coming up with some method of prioritization. We had to prioritize what buildings we were going to visit first. And rather than just put that in a first come, first served manner, we prioritized facilities that had a high level of importance to the community at large. These included hospitals and primary healthcare facilities, K-12, higher ed, first response facilities, and municipal buildings where community leaders would potentially be organizing their response efforts. So what would we do differently? The first thing we talked about is we need to take some time, now that the heat of the moment has passed, and review everything that we did do and discuss what we might want to do differently. We need to review the report format that we came up with and make sure that it had all the relevant information that would be needed by a building owner or by an authority having jurisdiction to determine the status of that building. Is the information clear? Is it presented in a concise manner? And are the findings clear? The next thing we really need to talk about is the issue of prioritization. Again, we talk about 300,000 buildings and 2,400 inspectors. The process of tagging buildings after a major event will be significant and it will be daunting, and that prioritization becomes a very significant part of that. How do we get the most important buildings reviewed and back online quickly? I'd compare the prioritization procedure to medical triage. MASH was the first thing that came to my mind. I had this image of litters of wounded soldiers on the ground outside the OR being evaluated and prioritized to determine who was in greatest need of immediate treatment. We're going to face something very similar to that following a really big quake. In the days following the Magna earthquake, we had a great demand to evaluate the condition and safety of a lot of buildings. We were able to quickly prioritize those facilities with a major community impact, evaluate them, and still review many other buildings needing review in a timely manner. In the event of this large quake, in addition to those major buildings, there will be hundreds, if not thousands of buildings that have to get some kind of prioritization process. So the need to have a more rigorous system and criterion for prioritizing that process is something we definitely need to investigate and generate as we move forward. The other thing we talked about was ATC 20 training. In the days after this event, that was a major topic. It's been a major topic of Jessica's and Jared's as we've gone through this presentation today. And in the aftermath, we realized that not 100% of our staff had this training. And we developed a goal that we, over the next year, would get all of our engineering staff trained and ready to go on this. But the other part of ATC 20 training is, even though a significant portion of our staff had already received it, it had been some time since doing so, and that there was a certain amount of rust in the cobwebs there, and that we realized we needed to hold regular refreshing seminars so that we're up to date on the requirements and the procedures, because we don't know when the next earthquake's going to come, but we're sure that when it does, we don't have time to hold a refresher seminar so that everybody knows just what they need to do in this level of training. So with that, we'll turn it over to some questions. Thank you.
All right, we have a couple of questions. I see one about the Fix the Bricks program. Jessica, could you help us with that? Is it limited to Salt Lake City limits?
Yes, right now that is a Salt Lake City program, and that there is some discussion about trying to expand that program beyond those limits, but ultimately it's Salt Lake City limits at this time.
Thank you. Jared, here's one for you, because I know you were at the City and County building. So the City and County building had some damage to plaster. Was there any structural damage?
Very little structural damage that we were able to observe at the City and County building. You know, that's one example that I think should be heralded as a huge success. I mean, that's got a base isolation system, and by every observation and evaluation we've been able to perform, the base isolation system at City and County did exactly what we hoped and expected it to do. All of the damage that we've seen to date at City and County has been cosmetic. Virtually nothing structural of any concern.
Thank you. Just scrolling through looking for other questions I may have missed.
So Julie, I have a few that I found in the question and answer section, not the chat.
Go ahead.
I typed a couple of answers. There was a question about, what is causing the damage? Is it old codes, bad design, poor construction? And so we have kind of a smattering of those things. We have some building types. For instance, unreinforced masonry, it's no longer legal to build those types of structures. So that is an example of an outdated building type. But ultimately, our code standards and our code minimums are really set at a life safety standard. So that's not to keep the buildings from being undamaged. It's essentially to get people out safely and to prevent loss of life and injury. So that was one of the big ones there. There's a discussion, Jared, maybe you can take this, about if we missed in Magna on the magnitude of the event, what does that mean for the big one, right?
Yeah, well, I think the Magna event threw into sharp relief that, despite our best efforts and the best technology and geoseismic engineering we have out there, there's still so much about the earth below us that we do not know. And every one of these earthquakes represents a significant learning opportunity that helps shed light on what we can expect. Truth of the matter is, we cannot know exactly what to expect. Every earthquake is as unique as every one of our fingerprints, which my primary takeaway from this event overall is that we need to latch on to those things that we do have a great degree of control over, such as how we detail structures. And I'm very confident in our ability to design structures to respond well with ductile detailing. And that even if the earthquake is significantly different, maybe even much larger than the codes prescribe, we can still design structures to respond in a ductile and resilient manner.
All right, I see a question here from RK. He says, how do Utah buildings differ from those on the West Coast?
I'll take that one, if I could. Now, the one thing that the West Coast has going for it that we don't have here in Utah is they've had earthquakes of this magnitude and larger with a lot greater frequency. And as a result, the unreinforced masonry buildings up and down the West Coast have been largely weeded out. You just don't find them with as great a frequency as you find them here in Utah. We certainly want to be sensitive to the many homes, businesses, and other buildings that are other functions that are housed within these URM buildings, but it's something that we need to take a serious look at here in Utah and figure out how we can, purge these buildings from our community, for lack of better description.
Yeah, it is something that's going to stand out in our minds for a really long time. Jessica, anything else?
Yeah, there was a couple others in here. Jared Ma wrote, were all the examples shown from the Magna earthquake in March? And yes, they were. They're all from photos that members of our staff took while we were out and about town or out being asked to evaluate a building. Let's see, how did previously seismically upgraded buildings perform? I think Jared and Dorian, you both visited those types of structures.
Yes, I did, and Dorian can chime in here as well. But as mentioned earlier on, the first building I looked at was the city and county building, and it did very well. Cosmetic damage only. The base isolation system mobilized. There is some repair work going on, but that building is 100% recoverable without any serious damage. Up at the state capitol, we know we had our retrofit there some 15 years ago now. Virtually no damage. The only damage that I witnessed up there was a frame from a fire extinguisher. The trim work fell out, and I'm not convinced that the earthquake caused that. Retrofitted structures did very well.
Dorian, do you have something to add?
Yeah, I was going to ask Jared. I didn't have the opportunity to look at a reinforced or retrofitted building, but I'm wondering about the tabernacle on Temple Square. Did you hear anything about how that fared?
I did not review the tabernacle. I know others in our office did. By accounts that I had heard, it did just fine. It's kind of the unfortunate aspect of earthquakes like this is when things perform exactly the way they should, they're not newsworthy. So we don't hear about them.
Jared, one of the buildings that we did look at that was retrofitted was the UP Depot downtown. Obviously a very old historic URM building, had been retrofitted around the time of the Olympics, and to the best of our investigation, it saw no damage. Another building that I personally looked at was about an 8-story building. It had been retrofitted, not a full retrofit, just an improvement retrofit back in the 80s. For the most part, performed very well. There were some concrete shear walls added at discrete locations, and a couple of those walls had minor cracking in them, but no other distinguishable damage to the building.
So there's a couple other questions in here. There was a question about how Reaveley goes about evaluating a building, and we essentially use the ATC 20 checklist, right? So one part I think I missed in my nervousness, ATC 20 is a program that has been developed over the years as structural engineers and emergency managers realized they needed a standardized system that would really streamline the process and provide the quality that was necessary. So ATC 20 is currently the gold standard for evaluating buildings. So if there's another question about ATC 20, if I'm ATC 20 certified, how do we let our local jurisdiction know who has certification and training? Right now, the Utah Seismic Safety Commission has a link on their webpage to recertify. Essentially, you're intended to recertify every 2 years. There's a quick online exercise to do so, and we can share that link with everybody if there's some interest there. And let's see, there's a discussion about the URM Free School Initiative. And I threw that one out there. There's actually a paper written by EERI, a white paper, that talked about trying to get those buildings replaced. And so right now there are several school districts, and I know that some of the others can speak maybe better to some of the efforts. There are a lot of school districts who are desperately trying to get those schools replaced. And some of the issues with the way we fund the construction of our schools, it creates a real hurdle, right? Because we need taxpayers to spend the money to replace the school. So there are some ideas in the pilot program with the mitigation dollars on how, we're putting ideas in there, how we can help our community react to this. Because as you can imagine, there's a lot of people that are attached to those lovely old charming URM buildings. So there's a lot of work to be done.
A question here about how architects can play a role in BORP. Jared, can you help us?
Sure. When it comes right down to it, the ATC 20 certification is not exclusive to engineers. Architects can become ATC certified, and they can perform the post-earthquake evaluations. As far as other roles that architects might play, one hope that we would have is that architects would help owners and others with whom they engage to be familiar with the ATC 20 program and the BORP methodology. I think just as being responsible stewards of our profession, it would be incumbent upon us to be educating building owners and managers to know what tools are out there and available to help them recover in as timely a manner as possible.
Another question from RK, can you discuss disproportion earthquake damage?
I'm not sure I understand the question.
Maybe RK can elaborate, or we can talk to him offline. Mm-hmm. All right. I see a question or a comment from Fred in regard to the trauma. And as someone who has experienced some PTSD from the earthquake, I can definitely relate. And there's some really good information online from the emergency response and in regard to that, into the anxiety you might have felt, the aftershocks that I thought I would feel that really weren't there. And I've actually stopped looking at the earthquake app now. So I know there is there is an ability to overcome and pass through that anxiety. Well, we really thank you for your time. It's been a really great conversation. And if there were questions that we missed or any comments, I encourage you to reach out to us. And then also, if you remember, there's going to be a quiz at the end if you'd like to get the learning unit credit. So please click on that link and take the quiz, and then also look for the webinar on AIA Utah's YouTube channel. So you can watch us again and again. But again, thank you for your time. We appreciate it.
Thank you.
Thank you, everyone.
Thank you, everyone.
Thanks for joining us.
Bye-bye.